Good morning. In this video we're going to be looking at simple unit operation, which is a pump. For this video we will be using a component list that consists of methane, ammonia, carbon monoxide, carbon dioxide, water, hydrogen. The basis we'll be using is the SRK package. That is because primarily the water ammonia mixture requires the SRK package to predict its properties properly. Going straight into the simulation environment, we're going to set up a stream. This stream is going to be called feed. It's going to have a temperature of about 35 degrees Celsius, pressure of 1 atmosphere. 1 atmosphere, not a 1 atmosphere gauge, but 1 atmosphere, which is atmospheric pressure. See, it says 0, but that's 0 gauge. Set up a mass flow of 1,000 kilograms per hour. Its composition is going to be mainly ammonia, water, and some hydrogen and methane. So the ammonia present is 25% ammonia. This is on a mole fraction basis. The water present is 50%. We'll add some CO and some methane. So the methane will be 0.1. Some CO, 0.01. Some CO2. And the balance, which will be 0.13, will be made up of hydrogen. Note, mole fraction is 1, so we've set up our stream. It's converged, and we can see that it has some vapor in it. Since this video is on pumping, we should be aware that pumps only handle liquids, and as such, we'll be using a separator upstream, and the separator will be used to separate the liquid from the vapor. So the feed, you're going to have your vapors and liquids. So now we'll see that the vapor fraction of the vapor should be 1. The liquid vapor fraction should be 0. And we're ready to send this liquid to a pumping system. Yeah. So the pump is found in your palette, right? And you basically select, I'm just looking. There's a pump. So you connect your pump. Your liquid will be your inlet. Liquid as your inlet. Your outlet is going to be your liquid 1. Remember your name as you see fit. The energy is going to be the pump dash Q, W, whichever you choose. They're telling you here basically that the pump has an unknown duty. Why would you add a pump to a flow sheet? A pump is added to a flow sheet for 2 reasons. 1, to raise the pressure of the liquid to some operating pressure that you require. And 2, to determine if a pump is used in a real process, what would be the duty required for the pump. And you can of course relate that duty to the cost of the utility to run the pump. So in this case, we have a desired pressure of 10 atmospheres we wish to get to. So we have 2 choices. We can put the pressure into the pump directly under the parameters tab. We can put in a pressure ratio or a delta P. In this case, if your delta P is 10 atmospheres, Your pressure ratio is calculated for you, and that is based on an adiabatic efficiency of 75%. You can change this efficiency depending on the pump that you actually have, and you can actually enter a pump curve where you would put in a polynomial fit of the flow, so that you can enter the polynomial coefficients and approximate what the pump curve is as given by the manufacturer. Here we can see that the outlet is 10 atmospheres gauge, right? And the power the pump requires to do this is basically just 254 watts, very small pump in this case, right? That brings an end the pump video. Thank you.